Our goal here is to just basically introduce you or to re-highlight, I'm sure you're all well aware of these as well, that about the different control approaches to heat pumps. And what we want to do is actually within our case study home is to actually apply these approaches and see what the differences are. Okay, some of these approaches can vary depending on the installation. Maybe the homeowner has certain goals and wants and intentions for the heat pump itself. It could be for greenhouse gas emissions, electricity usage, consumption, or just full out cost, and so on and so forth. So again, what we'll do today is just look at the different approaches. We'll see what's out there. We'll get into not quite a large rabbit hole in each approach, but we'll just describe them. And then we're going to be applying these approaches to our case study home and see what the impacts are and the changes that we can see. So we're going to talk mostly about 3 different approaches, but there's 4 of them listed over here. The one that we've already been talking about is that balance point in regards to the temperature dependence. So at some point, we'll just switch over to our supplementary or auxiliary heat at a certain temperature where the heat pump itself is having trouble, keeping up, fully or 100%. The next one there is a single point economic cutoff temperature, and today we're concentrating on fully electric systems. This concept here would probably come in mostly handy when we have a dual fuel gas backup system. Okay, so there's, as part of the NRCan's tools, which we're going to dive into after this session, there's a way to actually have the tool tell you at what temperature is it feasible to switch to the gas backup that's most economically sound. Okay. The next 2 are 2-stage controls. One is temperature driven and one would be time based, or like a droop kind of approach. So again here, as you're mostly well aware of, there's difference of controls depending on the different kinds of systems that we would have, depending on the backup. We're talking about a full electric system. We've been talking about it for most of the day today, how the auxiliary heat can work basically in conjunction with the heat pump. They can work simultaneously. So the control aspect from there would change. But when we have a natural gas backup, basically right now, I mean, there might be a few systems out there that some of you might say, I know of one, but they're not, typically speaking, the heat pump has to work on its own, and when the gas furnace backup comes on, they cannot work simultaneously for the most part. So the controls there would be different. So why should we care about the control approach? Well, the end consumer or the homeowner, your clients, they might have installation costs in mind, the cost to operate the house as to what fuel or how much, where the cutoff temperature is and so on and so forth, of how much the auxiliary heat is coming in versus the heat pump. As far as industry, competitive pricing and business case is always important. And we also want to reduce callbacks. So customer satisfaction and our business reputation really relies on that as well. When it comes to a larger, bigger picture, NRCan is obviously more concerned with energy management and the environment, and that would also include greenhouse gas emissions when it comes to any kind of dual fuel system. So for the sake of this segment, we did see that a 4-ton heat pump in our previous selection process would have been probably one of the more optimal sizes to go with so far. But for this, we were wanting to show you some numbers of a 2.5-ton heat pump system, just to see what those different control approaches would give us, because they had a bit more of an impact. So with this said, a 2.5-ton system, our actual balance point cutoff temperature would be at roughly at 3 degrees Celsius for this area. So with that said, this graph here shows how much of the heat pump operation is actually dependent on the auxiliary or supplementary heat, which is the red here, and the actual just full out heat pump operation would be in this orange here. And of course the blue is on the cooling side. You see here at the 3 degree cutoff temperature, we are still actually going with quite a bit of the auxiliary supplementary heat. So that'd be our control approach number 1 at at the balance point. Again, control approach number 2 was the economic side, so mostly for a dual fuel system. But in this case, we are looking at a fully electric, so we're going to jump to control approach number 3. So 2 stages, indoor temperature driven. So this first slide here basically is showing us a situation where it's not so cold outside, which would probably be most of the year here anyways, compared to Kamloops or Prince George. So basically at this point, it's showing the house being at 22 degrees Celsius, and as it does cool off outside and the home starts to cool off, the thermostat will call upon to turn the heat pump on at, let's say, 21.5 degrees, so a half degree difference from the set point of 22. At that point, the heat pump would engage and it would bring the home back to its set point of 22 degrees Celsius. Again, we're in a warmer climate, so there's no need for any kind of second stage here. But if you fast forward this to where we're in a bit of a colder environment, the same thing would happen at 22 degrees. Everything's fine, everyone's happy, thermostat is satisfied, everything's great. The house cools off a little bit for the outdoor temperature, and we're hitting at 21.5 degrees Celsius. The heat pump will engage on its own and will attempt to get back to our set point temperature of 22 degrees. In the event that the temperature keeps dropping, in other words, it's too cold for the heat pump itself to actually be satisfying the thermostat set point, at some point, if it goes down another half degree, the auxiliary or supplementary heat would then kick in and help the heat pump get back to that set point. Okay, so therefore using a little bit more, obviously a little bit more energy at that point because it's full of electricity. Another variation of this control approach for number 4 is a 2-stage but time-based. So the same kind of concept of, let's wait and see what happens, and then we'll help it out with auxiliary heat if needed. We're at 22 degrees, the temperature drops to 21, for example, and it will call upon the heat pump to kick in. At this point, instead of waiting to see the temperature keeps dropping to tell us that we need more help, it'll just say, if we haven't hit our set point temperature, within 15 minutes, for example, then we need some help. So then it calls upon the auxiliary or the supplementary heat to help along, and then, of course, get back to our 22 degrees Celsius. Thermostats. There's a lot out there, I'm sure you're well aware of. Manufacturer, specs or basically thermostats that are provided by the manufacturer within a specific system obviously would be the best to use. It's pretty well a fail-safe. There are some third-party ones out there that some are good, some are not. Some of the third-party thermostats may not be able to handle a lot of the approaches and a lot of the systems that you're also going with as well. Has anyone had any experience with thermostats that are third-party that have not been a good idea? What are the impacts of the various control approaches? On our case study home, again, familiar slide of all the information there. But as we apply the different control approaches, we're going to look at some of the outcomes in 3 different ways. What is the cost of the utility with each of the control approaches? How much is the homeowner paying out of their pocket? The next one is how much energy is being used. So yes, they're somewhat, correlated, but in terms of actual kilowatt hours or gigajoules. And then also we're looking at the greenhouse gas emissions as well. But in this case here, probably won't have too much of an impact because we're not really dealing with a dual fuel system. So when it comes to cost performance, our approach number 3, which is our 2-stage temperature-driven balance point cutoff, not cutoff, but balance point transfer of supplementary heat, and as well as the approach number 4, the 2-stage time, they came in pretty well almost exactly the same. Okay, so that was much better than going with the standard balance point switchover. Okay, because as you can see here at 3 degrees Celsius, we're using quite a bit of that supplementary heat in this particular case for this 2.5-ton system. Okay, let's keep that in mind. This is going out with the full electricity cost as well, I guess, on the second tier, which Gary was mentioning earlier, as part of the study. When it comes to the energy performance, energy consumption, again, the same story there, no surprise. Approach 3 and 4 came in pretty well exactly the same and was much better than the approach number 1. And just to say that in this case here, when we went from Kamloops to Prince George, these graphs changed dramatically throughout. So again, it really reiterates the fact that proper design load, proper, all these techniques that we're talking about today really do help to zero in on that install, not to exclude the control approach. And lastly, for the greenhouse gas emissions performance, again, the approach 3 and 4 were also preferred. So with that said, that gives you the option as the contractor to kind of dig in a little bit, have these options available. You can have a conversation with your clients, to see what they're after in regards to their retrofit. In some cases, a homeowner is probably looking at just saying, I want to get rid of my gas furnace, and I want to go obviously full electric heat pump system. Some might be just going, I want to rely less on a gas, fossil fuel. So I want a heat pump, hybrid, dual fuel system, what have you. So every different control approach can vary depending on the situation and even what the homeowner may be looking for. So again, in this particular case, approach 3 and 4 were ideal for this case study. What contributes to comfort? Obviously, continuous air circulation. Variable capacity is great. Adaptable controls, thermostat setup as well, that it's properly set up. A proper thermostat would definitely help. The homeowner education component, again, I can't stress enough how much, we see, visiting homeowners at home. Ex-home inspector from years ago and energy evaluations for homeowners, how much they don't know how their house works. It's almost mind-boggling, but I've always found there's a huge potential, even for some new home construction, the builders will take their new homeowners through the house and show them everything and how everything works. The homeowner might go, okay, that's fine and dandy, I'll forget this in 5 minutes, but at least that effort's been there. How to change filters, when to change filters, how to check them, what an HRV is and where the filters are. So what have we learned? There's a few different approaches that are out there. I'm sure you're already using some of them or have them available. Different thermostats that are capable of certain things. Manufacturer thermostats are usually pretty well a bulletproof choice. We've looked at some of the effects of the control approaches on our case study home. And yeah, that's about all I've got on that.